In this video, I'm going to talk about the potentiometer and the two applications of potentiometer. For that, let's initially understand how we are drawing a potentiometer. That is, we could draw the potentiometer in our circuit like this. Actually, potentiometer is a lengthy wire which is connected in the zigzag manner as shown over here. This is our potentiometer, and the two extreme terminals of the potentiometer are marked over here. Then let's mark this point as A and this point as B. You could see 2 points. This is the lengthy potentiometer wire, and if I am connecting the primary circuit into this, we'll take a connection wire from A, then we'll connect it to a battery. This is our primary cell, and from the negative terminal of the battery, we are connecting it to the rheostat, a variable resistor rheostat. Then we'll connect a key. Afterwards, we'll complete the circuit over B, and this is our primary circuit. Then for the secondary circuit, from the point A, I'll connect a wire. Then at the end of this wire, I'm connecting a cell whose EMF is to be compared. Then from the negative of the cell, I'm connecting to a galvanometer. From the galvanometer, we are completing the circuit by a slide contact which is called as jockey. This is the necessary circuit diagram that we should understand in order to study the potentiometer. And our task is to know about the EMF of this cell. To know about the EMF of this cell. Let the EMF of this cell be E. Then we will put the jockey at one end of the potentiometer. Then you could see the galvanometer deflecting in one direction. Then if you are removing the jockey from here and if you are inserting it over here, or if you are plugging it over here, if the galvanometer is showing opposite deflection, then the potentiometer circuit is ready for measurement. Okay, then you will carefully slide the jockey through the potentiometer wire until the galvanometer shows zero deflection, null deflection or zero deflection. At this particular point, we will measure the balancing length. That is, let's assume that at this particular point the galvanometer is showing zero deflection. Then this particular length is called as balancing length. Let me call it as L. Then the basic principle of potentiometer is the EMF of the cell over here, it will be directly proportional to the balancing length measured. This is the basic principle of the potentiometer. And it is important to note that the primary cell's positive terminal should be connected to the secondary cell's positive terminal itself. This wire has to be connected to the positive terminal of this cell, and this wire has to connect to the positive terminal of this cell. And the other important thing is, for this thing to happen, the primary circuit's cell should have a higher potential than the secondary cell's potential. Okay, therefore now we have understood the basic principle of potentiometer. Then we are going to use the potentiometer in two different ways. The first use of the potentiometer is in order to compare the EMF of two cells. We could use this potentiometer to compare the EMF of two different cells. For that also, we require the potentiometer and we have to construct a circuit diagram. The circuit diagram that we have to construct over here, it's like this. Pay your attention over here. We have to draw the potentiometer wire. This is our potentiometer wire. Then this is potentiometer wire means we have to construct our primary circuit. Let me draw the primary circuit. This terminal is our A terminal and this is our B terminal. The primary circuit is completed like this, as in the first figure itself. We will connect it with a cell, a given cell. Then we will connect it to a rheostat. Afterwards, we will connect it to a key and we will close the circuit. Therefore, the primary circuit is over. Then we have to connect the secondary circuit, and our task is to compare the EMF of two cells. In order to compare the EMF of two cells, we require two unknown cells, and that two unknown cells are connected by using two different wires like this, and we have to connect it to the positive terminal of the two unknown cells whose EMF is to be compared. And I'm connecting the positive terminal over here by two different wires. From the negative terminal of these two cells, we are connecting it to a two-way key. The name two-way key is indicating that we have to split the current flowing through the cells. Therefore, we'll connect it to a two-way key like this. The two extreme terminals of the two-way key are connected to the two cells like this, and from the center terminal of the two-way key, we'll connect to a galvanometer. Afterwards, it is connected to a jockey. This is our circuit diagram for comparing the EMF of two cells. And let this be our first cell. Let's say the EMF of the first cell is E1, and let this be our second cell. The EMF of the second cell is E2. Initially, we'll insert the key in the first gap of the two-way key. If we are inserting the key in the first gap of the two-way key, the first cell is in the circuit and second cell is not in the circuit. Then we'll measure the balancing length, that is the length in which the galvanometer shows zero deflection, and that balancing length will be the balancing length corresponding to the first cell. Therefore, I could write E1 proportional to L1. Let that balancing length be L1. We'll measure it. Then, removing the key from the first gap of the two-way key, we'll insert it in the next gap. If I'm inserting the key over here, the second cell will be in the circuit. Then we'll do the same thing, that is we'll measure the balancing length. And if we are measuring the balancing length, and that balancing length will be corresponding to the second cell. Therefore, let me write E2 proportional to L2. Our task was to compare the EMF of two cells. Therefore, from E1 proportional to L1 and E2 proportional to L2, I could write E1 by E2 is equal to L1 by L2. Thus, we have compared the EMF of two cells by using potentiometer. Therefore, this is one task of the potentiometer to compare the EMF of two cells. This is how we are comparing the EMF of two cells by using potentiometer. Then let's go for the next task. The second task of the potentiometer is to find out the internal resistance of a cell. The second task is to find out the internal resistance of a cell. For finding out the internal resistance of a cell, I'll draw a potentiometer circuit. That is, I'll draw initially the potentiometer wire. This is our potentiometer wire, and we'll construct the primary circuit as in the first and second diagram. That is, I am constructing the primary circuit, that is a cell which is connected to a rheostat, finally to a key, and we are completing the circuit. And in the secondary circuit, our task is to compare the it's not compare the EMF of cell. Our task is to find out the internal resistance of the cell. Then, in order to find out the internal resistance of the cell, we will take a wire, and the cell whose internal resistance is to be found out is connected like this. Then we'll connect it to a galvanometer, then finally to a jockey. Then you may have a confusion that the circuit is the circuit itself. Actually, these two are a same circuit. Now, then there is one additional thing that we have to construct over here. That is, from this point I am taking another wire, and it is connected to a resistance box and to a key, and I am connecting it like this. Okay, the additional thing is we are having a resistance box, a key, like this. Then this is the circuit diagram required to compare find out the internal resistance of the cell. Initially, we'll unplug this key. That is, assume that I have unplugged this key. If I have unplugged this key, this green circuit is not in the whole thing. Therefore, we'll find out the balancing length, and that balancing length is the balancing length corresponding to the EMF of the potentiometer, the cell that is connected over here. Therefore, initially, by removing the key in this circuit, we are finding out the balancing length, and that balancing length is corresponding to the EMF. Therefore, E proportional to L1. Let me write the balancing length as L1, and that balancing length is corresponding to EMF. There, as the second case, we are inserting the key in this cell. Then this circuit is also the part of this whole circuit. Then we will measure the balance length corresponding to the potential difference across the resistance box. In the second case, since we have inserted the key, then we will measure the balance length corresponding to the potential difference across the resistance box. Therefore, the second balance length will be corresponding to the potential difference. Therefore, I have to write V proportional to L2. Then I could write E by V is equal to L1 by L2. Then from this, or from our previous class and all, we know EMF is equal to I into R plus R. We have learned an equation like this, in which I is the current flowing through the circuit, capital R is the external resistance, and small r is the internal resistance of this cell. Then from our Ohm's law, we know V is equal to IR also. This is another expression that we know in our earlier class. I am substituting for E and V in this equation. Then I could write I into R plus R divided by IR is equal to I capital R is equal to L1 by L2. Then we could cancel this I and I. Then I could rearrange, that is, we could write R by R plus small r by capital R. Then I am writing it like this: 1 plus small r by capital R is equal to L1 by L2. Our task is to find out the internal resistance of this cell. For that, I am retaining the small r by capital R over here. Then I could write L1 by L2 minus 1. Then from this, small r is equal to capital R into L1 by L2 minus 1. And this is the next task. That is, our task was to find out the internal resistance of the cell by using potentiometer, and this is how we are finding out the internal resistance of the cell by using potentiometer. Small r is the internal resistance of this cell. Capital R is the external resistance, or the resistance which is in the resistance box. L1 is the balance length corresponding to E1 or balance length corresponding to EMF, that is if the key is open. L2 is the balance length corresponding to the potential difference or voltage, that is if the key is inserted or the circuit is closed. Okay, hope you understood this. Thank you.